So I gave you kind of a big picture before, and now I want to get more into specific findings that we had for this study. So the topic for this presentation is going to be life-extending benefit of microsurfacing and combination treatments, and this is going to be in terms of roughness. But that's a good idea of the process that we typically follow for any other treatment and any other metric. We all know microsurfacing is a very popular preservation treatments. If you go back to those surveys that we talked about before and information that you may find out there, you find estimates for life extension anywhere between 4 and 10 years. If you combine your microsurfacing with other treatments, let that be crack sealing or a chip seal or a scrub seal, then you could definitely expect more than that. Now we're focusing on roughness and specifically for cold regions. So that's a very unique environment. You're going to have repeated traffic loads, but also that frost action. And if you see those high severity transverse cracks like I showed in the previous presentation, then you can definitely expect very rough pavements. So specifically for this presentation, the objective was to evaluate the effect of microsurfacing and combination treatments on roughness. And this, again, is looking just at our Minnesota test section. So we have, again, our data from the PG study, specifically Minnesota, and we're using both the low traffic and the high traffic pavements. Now, to give you, again, more information on where those test sections are, that's in about, I think, a 40-minute ride from Main Road or so. So we have US 169. It's high traffic. It was about 7 years at the time that it was constructed, 7 years since the last whatever was done to the surface. We have there 6 different microsurfacing sections and also 8 control sections that we've used for this study. And then very conveniently, the low traffic location, because I-8 is just off of that one, US 169. And this one's low traffic, but it's got like a lot of farming equipment on it, a lot of husbandry equipment. That one was a little older than US 169, and again, we have 6 different microsurfacing sections and 8 controls as well. So these are our test sections. We are going to have single microsurfacing, single layer. On US 169, that single layer microsurface has fibers. The one on CASA 8 does not. Then we have the single layer microsurface with crack seal. On US 169, we have some longitudinal mastic kind of towards that outside edge stripe. And for CASA 8, we have the mastic on those transverse cracks, so it's transverse mastic. Then we have double layers. Then we have a cape seal, which will be the combination of a chip seal and a micro. And then we have a fiber mat chip seal with a micro on top and a scrub seal with a micro on top. So all of those in the 2 different locations. Now, for data collection, what we did, obviously, we got the IRI before construction, and then after we applied the treatments, we kept measuring IRI on a regular basis. Minnesota being Minnesota, we don't have data collection in the winter months, but we pick it up again in the spring. So there's a little bit of gaps in there, but we're able to fill them up once we have several years of data. And we're also looking at other indicators. So again, cracking, rutting being the main thing, especially because they're used for MAP 21 evaluation. What we did was take the rutting or the IRI data and just develop different models. So we used an exponential form that has been proven to be effective and just be good demonstration of how our IRI progresses in the sections. And we did that individually for each location. So our IRI model is a function of the IRI that we get right after treatment and then time. And that beta parameter that you see there is just our deterioration rate for the different sections. So this will be for our treatments, but we also did it for our untreated pavements. And because we have several control sections, we just kind of group them depending on where they were in terms of IRI before construction. So again, looking at the parameters from the map 21, if we have several sections that were considered to be fair before treatment or before all other sections were treated, we will group them and get the model for that group. And same thing with good payments. We didn't have anything in the poor category, so it's either a payment for a model for a payment that was in good condition or a model for a payment that was in fair condition. So we combine and again get a deterioration rate for those. And the methodology goes something like this. We're going to have our graph, so there's time and there's IRI, and we're going to have a payment that doesn't get any treatment, so we develop a model for that one. And then we're going to have a payment that got some treatment, and we get a model for that one as well. So hopefully there's a difference between those two, and that's what we've been seeing. And the benefits, we can look at them as an immediate benefit. So we either get an instant reduction in the IRI, what we're calling the performance jump. So that will be our immediate benefit. But we also want to see the benefits over time. So we thought, well, our threshold is going to be that number that divides or that determines when a payment gets to the poor condition category. In our case, is going to be that 170 inches per mile for the poor treatment category. So we're going to see, well, what's the difference between the time that it takes to get there for an untreated payment versus the time that it takes for the treated payment that was in the same condition to begin with. So that's our life extending benefit, just kind of measuring there in the horizontal direction. And then our condition improving benefit is how far apart those curves are from each other. So at any point in time, it may be that they're just parallel and the benefit is just the same no matter where you are in time, or it may be like they separate a little bit as time goes by. So we can just determine that at any point that we want to see it. So now on for the results, which is what we want to see. These are side-by-side pictures, and they were treated at the same time, so they're the same age. You can see in the left we have US 169, and on the right we have CASA 8. And you see at the bottom the different curves for the models that we developed. So we always see this. The dashed line is going to be the untreated, so it's going to be rougher, and then the continuous line is going to be the treated payment that gets that immediate benefit because you see it drop right there at time 0, and then over time, sometimes they're closer, sometimes they separate more, but basically for US 169, we are right now at year 6, so anything that you see beyond year 6 is a projection, and we projected up to year 10. We didn't want to get too much into the future. But for US 169 at this point, the control section, if we didn't treat it, we'd be in the fair condition category, but because we treated the section, we're in the good condition category. And they're not expecting either one of them to get to the poor threshold, not even within the 10-year period. That is not the case for CASA 8. So the untreated section is already pretty rough. It's already in the poor condition category, but the treatment is not. So this is a single microsurface for both locations. And you can see in that corner with the text how it's doing in terms of the other indicators. So again, we said rutting is not a big deal. Cracking, the one on 169 just went over the 20%, so it will be poor. But if you look at the picture, that's also important to see the type of cracking that we're experiencing in there. For CASA 8, we're still fair condition for cracking. Rutting's not a concern. The IRI is pretty rough at this point. Moving on to the single micro with mastic or crack seal. Again, we see the same thing, so we get a little bit of a reduction. If you don't have too much roughness to begin with, that performance jump is not going to be as big because there's not as much room for improvement. If you're rougher, then you could probably expect to have a bigger difference, but also the importance of how that sustains over time. So maybe you get a bigger benefit immediately if you're rougher, but if you're not, that benefit is going to sustain more over time. We can see there again for 169, we're not anywhere near the poor threshold for IRI. The one CASA 8, if we don't treat it, we can definitely expect to be there at this point. But with a treatment, we're able to minimize that. And let's see. Next one will be the double microsurface. So one thing that we've been very impressed with is the difference that it makes to have either just the single microsurface or the double. It doesn't seem like much. It's a very light treatment, but if you have those two layers, you exponentially improve those benefits. And you can see, for example, on 169, that projection of IRI over time for the treatment is almost like a flat line. If you don't treat it, you can expect to be rougher and rougher as time goes by. And even CASA 8, where the conditions are so rough and you had so much cracking and transverse cracking that was affecting ride, and we started pretty rough at like 130s or something like that for the IRI. We've been able to get a benefit in time in addition to that immediate benefit. So we keep seeing that consistently. There's always something to be gained in the beginning, and then that over time we're always different than what we would be if we didn't do anything. Moving on to the combination treatments, this will be the Cape Seal. It's a chip seal and then a microsurface on top. There's not a lot of benefit in the beginning, but we're starting pretty low anyway. And then the curves are still separated as time goes by, not as much as we've seen with other treatments. I think the chip seal by itself tends to be pretty rough, and maybe just the one layer of surfacing for the micro on top, it's helping, but not as much as like the double micro, for example. So that's something interesting in there. But if we look at other combinations, so for example, the FiberMat Cape Seal, then it seems to be doing a better job of giving us a benefit. I think the FiberMat having those basically 2 shots of emulsion, a lot more liquid in there, maybe that's helping filling some of those voids and getting it less rough. And then the cherry on top is putting that microsurfacing there. And you can see in terms of other indicators, a lot less cracking, a lot less rutting, so overall performing very well. You can see the projection or the model for the treated pavement. Again, it's almost like a horizontal line. Even for CASA 8, it seems to even go decreasing in time, which I will just say conservatively, it didn't change. It's rare that it will just go down. And then the last one would be the scrub Cape Seal. So we have a scrub seal and then a microsurface on top. Again, it helps with roughness. It also helps decrease a lot of cracking. We don't really see any significant rutting. So overall, after 6 years, this is what we're looking at in terms of performance. And again, the difference between the two curves and how they separate over time and how we're projecting one pavement to get to that poor condition threshold versus an untreated pavement is really what we're after. So let's put that in a table. Let's see the life-extending benefit. Again, the difference in the time that it takes to get to poor threshold between the treated and the untreated. And then the condition improvement benefit is at year 6, which is where we are right now. What's the difference vertically, that separation between the two curves? So you can see there, life-extending benefits in US 169, the least we got was about 5 years. And then there's some sections that we could say it's at least 10 years that we're going to get of life extension, especially if we're doing combinations or the double layer. For CASA 8, where the conditions were a lot harsher, we can expect less, but still there's some sections where we're even seeing a projection of at least 10 years of benefit. Something to highlight also is how those sections were in terms of roughness at the time of treatment. So most of them were less than 95 inches per mile, so what we will see as good condition. There were some that were in the fair condition category, and those got the less benefit in terms of life extension, but we still got a benefit considering how bad those cracks were and how rough those pavements were. I think it's worthwhile. And reductions in IRI, anywhere from 22 to up to 59 inches per mile less roughness for the treated pavements compared to the untreated pavements. So we definitely see benefits across the board. We see more when we combine different treatments, but even with a single layer, we can see a significant benefit. And this is all in terms of roughness. We've done the same thing in terms of cracking. We've done it for other treatments, but this gives you an idea of the process that we follow to quantify those benefits. So let's look at the other indicators, and just as an average of the treated pavement versus the untreated pavement, where we are in terms of those MAP 21 indicators. We always see better numbers when we treat the pavement, which obviously is what we were expecting. One thing here to note, the cracking on US 169, we see less for the untreated, but that is because we already replaced 2 sections that just were not in good condition. So those are not included in this average. But that will give you an idea. We already had, out of the 8 sections, 2 that went out of service because they just were not performing. Everything else, it's at a lower level than what we have for the untreated. And the same thing goes for CASA 8, so a little smoother, even though they're both in the fair condition category. A little less cracking and a little less rutting. So overall, again, treatments outperforming the untreated, which is what we were expecting to see. So to get us back on track here with time, microsurfacing can help us offset that roughness deterioration. It's definitely an effective treatment to do that, even in the harsh conditions that we see with the cold winters and transverse cracks. We can see life extensions of 10 years and more. We'll see. We didn't dare project to 20 years or so because anything can happen between now and then, but within those, we can see that we could have 10 years easily. Current IRI reductions, anywhere between 22 and 59 inches per mile when we put down a treatment. And we also get a reduction in the other indicators, so cracking and rutting is also less when we put down those treatments. And if we're using the Cape Seals, to me, that's the winning combination. We get the best from both worlds. So with that, if there's any questions, I'll be...
Dr. Vargas, a couple of things. Of course, that's great information, but for this crowd, it's probably important to know that CASA 8 had some of the most extensive thermal cracking that I've ever seen. I wouldn't even lay my pen down next to these cracks to take a picture because I was afraid I'd never get it back. And it changes dramatically. But another contributor that you need to know about is the aggregate that was used in the microsurfacing was a type 2 that was about 98% passing the number 4 SIB. So it was a fine material applied at somewhere between 18 to 20 pounds, where in most typical sections, if you're trying to improve the IRI, you might want to use a type 3 aggregate at 25 pounds. So you're looking at about a 35% increase in material applied, and especially when you go to the double, you could really see some increased IRI advantages to doing that. We did use type 2s and 3s in the South study. We only used type 2s in the Northern study. So that's one of the big takeaways. They need to be aware of that factor.
And just to put a plug in there, that's why we're doing our bi-monthly meetings, so we can go into that level of detail with the materials and the construction and all of that we don't normally have time to talk about during meetings like this.
Great work.
Thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.